first step is to look at it and say, okay, which side is simpler? The left has fractions, the right has things subtracted. There's not necessarily a right or wrong, but maybe an easier and a harder path sometimes. So it might be easier to try to get rid of the fractions. Maybe not. I don't know. We'll try it and see. If we get stuck, what other option do we have? Yeah. We work until we can't go any further, then go work the other side and see if we can get it to the same point. So, any obvious identities jump out from here? No, not really. So, if there's no other obvious starting point, what have I told you to do?
Sine, cosine.
What is tangent?
Sine over cosine.
And I told you yesterday, make sure you're keeping the variable that's given. So, sine t over cosine t.
Oh, but I don't like the t.
Minus, what is cotangent?
Cotangent, or cosine over sine.
Okay. Look at our goal. We still want things being subtracted, but I no longer want it to be written as a fraction and a fraction, do I? How do we get rid of fractions and fractions? Multiply by the reciprocal. Okay. This is just over 1. So the top of the fraction wouldn't change. Now we take it times and flip this 1 over sine t cosine t. What would you have to do now? Distribute. Okay. If I multiply these, on the top I would get a sine. On the bottom I have a sine. Cosine squared. These, the top will give me a cosine. The bottom would be sine squared cosine. Okay, right now it looks like things have gotten uglier, but actually we are in good shape. Because this is all one term, so we can cancel. So sine on top and bottom cancel. We're left with 1 over cosine squared, which is and this one, the cosines drop, so we're left with 1 over sine squared, which is, and that was what we wanted. So we boxed it in to show that we have completed our problem.
I have a class. I had a track.
I got over at some point.
I got yelled at by a lady. I went home and cried. She was very scary.
Any questions on that one? Let's try some more. So we're just practicing the same thing over and over again.
I keep getting pranked by these 1 minus sine x because they're not squared.
I know. You want to make it the cosine squared. No luck. Alright. These are practically the same. Is one obviously easier than the other? Not really.
Cross multiply.
We can't work both sides at the same time. Although you might get to a point where it's like an equation, but we're trying to prove one, so we want to leave one of them alone. Alright, box in the left one. Grant made an executive decision.
Grant, what was your basis for this? Why'd you box the left one?
Oh yeah, love.
Definitely, without a doubt. Alright,
Why?
any obvious identities on the other one?
No, we could break it apart into 2 fractions.
Okay, we can, but keep our goal in mind. What's our goal? Our
To get the
goal
other
is to get a single fraction, right?
Wait,
So breaking them apart, while it's an option, probably not going to get us
Right.
closer to where we want.
Multiple reciprocal?
Yeah, hold that thought.
Okay.
So no obvious identities. So the next thing I tell you is change sines and cosines, but we're already there.
Yeah.
So there's really not much of anything I can do to simplify right now. So keep your goal in mind. Okay, my goal, I want a cosine, and I want a 1 minus sign. Do I have a 1 minus sign in here anywhere? Okay, is it legal to multiply the top and the bottom of the fraction by the same thing?
Yeah, multiply by -1.
Well, -1 would make it negative 1 minus.
Oh.
Make it. Why don't we just multiply by the 1 minus sign? Okay, we don't really have any options for simplifying to that point, but we can multiply the same thing on top and bottom. If you multiply on the top, what would we have to do? FOIL, so we get 1 minus sine x and plus sine x cancel. Minus sine squared x. And bottom, I'm not going to distribute this because my goal, I want the 1 minus sign, so I'm hoping I can make this cosine disappear somehow. So I'm not going to distribute that. Any ideas?
Well, I have an idea, but why, how could we multiply by 1 minus sine of x if we, that side that we're working on, we just treat that as if there's nothing
Okay.
to equal it to?
So just think about like when we want to get a common denominator, we multiply the top of the fraction and the bottom of the fraction by the same thing. So that's kind of what we're doing here. We know we need it in here. There's nothing I can do to make this turn into it, so I'm going to multiply by it. But if you do it on top and bottom, they essentially cancel, so you haven't changed anything.
The top
The top
would be
equals
cosine squared.
Okay, 1 minus sine squared is cosine squared.
The cosine will cancel out now.
And now I can cancel one of the cosines. And I'm left with
Cosine.
I feel like this is pretend math. Like this isn't.
It's proving. It's giving justifications
Well,
for things. So it
not-
kind of goes back to like geometry proofs.
Not just this. Oh, I didn't take that class. Not just this, but the stuff we did the other day. Like this feels like something you gave to a kid, and you were like, "All right, I'm gonna go do something for 30 minutes. You figure this out."
It's more of a being able to write them in equivalent forms. So just getting used to manipulating with trig functions. We're so used to doing it with algebra, with numbers and x's, but it seems like when we throw trig functions in there, it confuses everyone. So we're just trying to get comfortable with them. Any questions on that one? Let's try another.
Pranks again.
Box in the right one.
I concur.
Grant says the right one needs to be boxed in.
I concur.
Okay.
I second the motion to box the right one in.
And remember, there's no right or wrong here. That's why you're showing your work. So you can do it from either way. So if I box in the right, what do you want to do with the left?
First, make the cotangent in sine and cosine.
Okay. We go to sines and cosines. Cotangent squared is
Cosine. And then multiply by the reciprocal.
okay. So the top 1 plus sine x times, if you flip the bottom. Okay. Keep our goal in mind. I want a sign on the bottom. So I don't think I'm going to distribute my sine squared, just because sine cubed is not anything. And I really need a lot of this stuff to cancel out if I'm going to get anywhere near what I need.
Are we quieter when we walk through the hallway?
Yeah, this is probably the loudest hour. No, it's 5th and 6th hours are too loud.
I feel like we're really quiet in the hallway, but then we have Aiden in that class.
The last
In the
hour.
hall.
Yeah, in the hallway. Oh, wait, what happened here? I got kind of lost.
I just flipped and
How
multiplied.
did the signs cancel out?
They
It's on the
didn't.
bottom. My signs left. This isn't
They did.
on the bottom.
Oh, so we're trying to divide by it? We're not doing this. We're not doing the top, it's just we're trying to divide by this thing.
I don't care.
Okay.
So
So,
we just flip them
to flip and multiply, we keep the top as it is, times, and we flip the bottom, get the sine squared, and get the cosine
We're
squared.
not gonna do that, we're just trying to divide by this.
Like, it comes up,
What's
right,
next?
so the bottom is gone. 'cause you
Oh,
fixed-
right, because it became one.
Yeah, so then I just kept the top
Gotcha,
as the
gotcha.
1 minus sine.
Okay.
Oh, wow. Ooh, gremlin sounds.
Look at where we're going. We need a sign left on top, but that means I have to get rid of the 1 plus sign and another sign. I need a cosecant minus 1 on the bottom. Any idea?
Can we distribute one sign?
We could.
Wait, no, wait, never mind. I thought that I read that wrong. Never mind. Dang, I screwed us over when I started this.
Can we
I
split
mean, you
it?
weren't wrong, but it's not helping us get closer.
Can we split it?
Oh, I see what she means. Like splits the.
We
Or is that not gonna
can,
help?
but
like
it's,
one fraction.
we're really just wanting a single fraction, so splitting into multiples isn't getting us closer.
No, but if we split it into. No, wait, no, never mind. I played myself. I've played myself.
Or we
Box
can,
it.
Could you
can
turn it-
box it in.
Could you
we can box it in, try working the other side, that's an option. What were you gonna say?
No, my thing's not right.
Are you sure?
Yeah, cause I was gonna say someone turn that into tangent.
Okay, you could make it like put those together, so it'd be 1 plus sine x times tangent squared x. That's
And then-
true.
I think no, but I think that kind of is right
And
because
then
we need
we can do, can we do?
because we kind of need tangent to get cotangent to get cosecant.
Okay.
Well,
So all the things you guys are saying are legal. And they'll get us there eventually.
That is not helpful.
But it's gonna take.
But these are gonna be some pretty long paths.
So boxed in.
Can I give a different suggestion?
Yes.
Okay, let's go back where we started.
I'm sorry, guys.
No, you didn't. I mean, this is how it works. Sometimes you do something and you realize you're getting further and further away from where you want to be, so you're thinking, what else could I have done? On the original denominator, we had cotangent squared. Look at your goal. You want a cosecant.
Cotangent plus 1. Cotangent squared plus 1. We should have
If you look at your
put a 1.
Pythagorean identities,
Is cosecant minus 1.
so this would be cosecant squared minus 1.
Did you multiply the top and the bottom by something that I missed? How did you? Oh, but there's no plus 1.
Cotangent squared.
I see.
All right.
Do we do like difference of squares or something?
Yeah. What if we factor the bottom?
You can factor a positive and a negative 1.
Okay. We want the cosecant x minus 1, don't we?
So multiply the other one.
So we need the other one to go away.
Wait, what's cosecant sine? 1 over
Okay.
sine.
Cosecant is the reciprocal of sine. So there's some different options on what we could do here. We really need some things to cancel. We want to keep the cosecant minus 1. That means I need a plain sign on the top. What if
We multiply.
I multiply top and bottom by sine?
That works. That gets rid of that bad boy.
Okay, so the top, I want my sign by itself, so I'm not going to do anything with it. I'm not going to distribute because I need the 1 plus sign to cancel. On the bottom, you can multiply any two in any order. So if I multiply those, sine times cosecant, what would that give me? 1 plus sine, and then I have my cosecant minus 1. And then The 1 plus signs cancel. And we have what we want. Now, was this the most direct route? Probably not. This one, it might have been easier actually to work with the right-hand side and just multiply by conjugate on top and bottom. But we got there. Okay, sometimes you try something, it doesn't work. You try something a little bit different until you make it pan out.
I figured this. I didn't realize the cosecant had a +1 already, and I was trying desperately to
get
figure
it.
out where'd that one go?
If we had worked the other side, just to kind of show you, I said that might have been easier. You could have multiplied top and bottom by cosecant x plus 1. The conjugate. Sine times cosecant would give us 1 plus sine.
Oh wow.
On the bottom, if you FOIL, you get cosecant squared minus 1 and cosecant squared minus 1
Cotangent squared x.
is cotangent squared x. So if you'd worked the right hand side, that might have been a bit easier. But we got there. Alright, let's keep trying.
Oh, that's a lot of C's.
That's a lot, isn't it?
I
Box
think
on the left side.
we got box on the left side.
It's gonna be the left side, we're not going to the left side, because we want to do the right side.
No, but I think the right side will be. Wait, we're trying to get cosecant. No, but that gets sine, and we don't need sine, so we shouldn't box in the right side, the left side. I think that would be unhelpful to our case.
Do both of them? It might be. They're both pretty ugly. A lot of times when both sides are pretty ugly, that's one where you end up working until you get stuck and working the other.
I think we should work the left one out first.
Maybe they're both fractions, so they're both equally ugly there. But if I look, the left has like cotangents and cosecants, whereas the right is sines and cosines. So maybe it would be easier to try to work with the left for now. And we know if we get stuck, we'll come back and work the other one also.
Okay. It sounded like you were saying that's not what I said, but that's what I said, so I got confused.
No,
It's
that's what
fine.
you said.
It's fine. I just lost. I got lost.
All right. What do you want to do? Give me an option.
Sine and cosine everything.
All right.
Actually, wait. Can we cancel our cotangent stuff first?
We cannot because
Because
more than
they're
one.
separate. Yeah. Okay.
Cotangent is
Cosine over sine.
cosecant is
1 over sine.
please if I do that on top and bottom.
And then we could just.
Couple different options here.
We shouldn't do the conjugate. I think that would hurt us more than it would help us.
Why by the conjugate?
We can.
That would get rid of our whole bottom, though, wouldn't it?
How about we have lots of fractions here,
I
right?
think we should reciprocate.
What is every single one of these denominators?
Oh, GCF it out.
So, yeah, what if we know we can multiply top and bottom by whatever we want. What if we take everything times sine on top and bottom?
Sounds like a smart idea.
So cosine over sine times sine would just give me a cosine. 1 over sine times sine is 1.
And then we should conjugate.
On the bottom we have cosine plus 1. So we've cleaned this up a lot. We're still not quite where we want to be. So we have to figure out what we might do there. So you're saying conjugate?
I think that's.
Yes, Tyler.
Well, if we just like box that in with the other side now, since it's really fun.
Yep. So you have either option. If you want, you can multiply by conjugate. I would choose conjugate of the denominator.
Right.
Or we can box it in and work the right hand side and see if we get to the same point. Okay. Which one do you guys prefer? Raise your hand if you want to keep working with this side. Okay, raise your hand if you want to work with the right. Alright, right hand wins. But if you want to go with this, multiply by cosine minus 1.
So then we box that in.
So we're going to box this in. We're going to go back and erase this box because we said,
I feel like we're playing a game show right now.
let's go try over here. What can we do on the top?
Take a cosine out.
They don't all three have a
Oh,
cosine.
wait, yeah, you're right.
But couldn't
We could do a Pythagorean.
cosine squared breaks into cosine?
Flip and not stepping stone, but.
Like the easy method. What two numbers multiply to 1 and add to -2?
-1 and -1.
Alright, think about my goal. My goal now is only things with cosine. So we have a negative. What is sine squared?
Cosine,
Cosine
one minus
squared.
cosine.
1 minus cosine squared. Okay, so on the bottom, it was a negative. So if I distribute that negative, it would give me a positive cosine squared minus 1. Good. Sine squared is 1 minus cosine squared. So if you distribute the negative, you get negative 1 plus cosine squared. What can you do to cosine squared minus 1?
Sine squared.
It can go sine squared, but I don't want sine squared.
Oh, you can, yeah, you can difference.
Difference of squares, that's cosine theta plus 1. Cosine theta minus 1.
And then we can cancel out a minus 1.
It's the same thing, we got it. If you had started multiplying by the conjugate, you would have basically ended up here and then worked backwards, multiplying it all out. So it was really the same amount of work no matter which way we did it there.
Oh, I didn't remind. Squared. I did, but I took it right.
I can do it by myself.
You think you can?
No.
That's why we're still practicing.
Would I need, like, since I did the conjugate and work backwards, would I need to do that negative 1 minus cosine squared, or would I just see
You would
that?
have to factor out. So if you multiply by the conjugate, you would end up with cosine squared minus 1 on the bottom.
But would
So,
in the
if you-
equation, could I just subtract
Yeah.
over and then add sign, well,
Yep.
subtract sign over? Okay.
Yep. So if you got it from there, that would have been fine.
How many more samples are there?
I don't. We'll see. So you guys act like you're confident.
I just have to really so
Try another.
What?
All right. Work with the left or box in the left. Box. Grant really likes a challenge.
Grant, why are you picking the harder ones?
It's already in sines and cosines.
It is in sines and cosines.
But it's fractions.
It's a lot of fractions.
I think we should simplify the fractions out.
Okay, so it can be done either way.
I wanna box on the other side.
Probably a little bit easier to put fractions together and try to get rid of it than to try to create fractions out of nothing. But it's not like you can't do it the other way. So we can work either one. But I think our shorter route would probably be to box in the right. Now, we may get stuck and end up working with the right too. We don't know. If you want,
We have to make the bottoms the same, right? So we have to multiply each other by each other.
okay, if we're going to add or subtract fractions, we have to have a common denominator. So I would have to take this one.
This is the first example I saw in the video, and it made me want to cry.
Okay. Let's see what happens. So if we start distributing, we get a sine x plus sine x cosine x. On the bottom, 1 plus cosine times 1 minus cosine is 1 minus cosine squared. Alright, in this fraction, we get sine, cosine, minus sine, cosine squared. Over 1 minus cosine squared. Definitely far from beautiful, but we do have a common denominator now
Now we should get
of 1 minus cosine squared x. So we can put these together. I'm going to go ahead and make this a plus and distribute my negative. So when I put them together, I have a sine x. But my sine x cosine x and negative sine x cosine x cancel. Okay. We are actually super close to the answer.
Bottom side square.
Yes.
After the cross multiplying.
We got a common
Oh.
denominator, and now we're just adding the tops.
Where'd you get the 1 minus cosine squared x?
The denominator when you multiplied out the, like we multiplied this one by 1 plus cosine on top and bottom. If we look at our goal, we want things multiplied. So that means factored. On the top,
You factor that sign.
whoa, I added in something extra, didn't I?
Well, you distributed it in the
Yeah,
beginning, and then you
sorry.
took it
I
back.
think I was a step thinking through the next step in my head, and I wrote down part of what I was trying to do and part of the next step. Sorry about that. The top, we're just adding those. Is that why you guys were confused?
That's why.
Yeah, yeah. So now on the top, what I was thinking in my head and wrote down, we want things multiplied. What do both of these terms have?
They all have a sign.
If I take out the sign, sine divided by sine is 1. And this term, if I take out the sign, that's plus cosine squared x.
That's cosine squared. Hang on, I got lost. That's sine again.
But look at where we're
Yeah,
going.
I know, I understand.
Yeah.
Oh, we need that.
We need that. We don't want that to go away. If you have a sign on both top and bottom,
You just divide out.
Wait.
Why do you have sine XX on the bottom? Is that the 2? Okay.
yeah,
I
it's a
understand.
sine.
And then that equals cosecant.
Yeah. So what we're left with is a 1 times sine, or 1 over sine times a 1 plus cosine squared. And 1 over sine is cosecant. And we got that. Work and ask questions. So they're yesterday's, which hopefully you started and you know if you have questions on. And here's another chunk.